So hello students, welcome to this chapter, Reflection and Refraction. We'll talk about refraction by spherical lenses or spherical surfaces in this particular topic or in this particular video, right? So let's start with lenses, right? Now, what are lenses, to be honest? I'll first explain you the definition and then we'll start about knowing the reflection part of it, right? So lens is a piece of transparent material with two refracting surfaces, right? Such that at least one is curved and refractive index of its material is different from that of surrounding. Let me write it. A lens is a piece of transparent material, right, with two refracting surface such that at least one is curved. Yeah, it is not necessary that both the surface have to be curved in a lens. This is the wrong misconception which everyone has. The main definition is at least one curved surface should be there, and the refractive index of its material is different from that of the surroundings. Right? Now, how a lens behave as converging and how a lens behave as diverging, that I'll explain it to you right now. A thin spherical lens with refractive index greater than that of surrounding behaves, sorry, behaves as a convergent or convex lens, right? That is, converges parallel rays if it's central. That is, paraxial portion is thicker than marginal one. So what is paraxial and what is marginal? So the middle part is paraxial, right? Right? The middle part is paraxial and the corner part is marginal. So it says that the middle part would be thicker than the marginal ones, right? It will be marginal ones will be thinner. So let me draw the diagram. Before that, however, if the central position, what was the central position? It was paraxial. The central position of a lens is thinner than marginal. It diverges the parallel rays. Right? And behaves as a divergent or concave lens. Right? Any doubt till now? So this was the way to classify which one is convergent, which one is divergent. Now I will tell you 8 different type of lenses. Generally, people say there are two type of lenses, convex, concave, but I'll tell you 8 different type of lenses. First one, this is convex from both the ends. So it can be said as biconvex lens. With different refractive index, R, different radius of curvature, R2. Then equiconvex lens. With the same radius of curvature, RR. Plano-convex lens. Here, the radius curvature of plane lens is obviously infinity, right? The other would be R. Concavo-convex lens, right? R, R2, right? Now, now I'll talk about biconcave lens, right? Next, equiconcave lens, right? Then plano-concave lens, right? R1 infinity. Then convexo-concave lens, one side is concave, one side is convex, right? I hope you got it. Now I'll talk about optical center. What is optical center? How can we define optical center? Definition is O is a point for a given lens through which any ray passes undeviated. Any ray passes, this is the important point, undeviated, right? That is, we'll take two examples, one for convex, one for concave, right? Now, if this is optical center O, then any ray passing from this point will leave undeviated, right? If this is the optical center, any ray passing through it will leave undeviated. Got it? It's concave lens, convex lens. Given these two are optical centers, got the definition, right? Let's talk about principal axis. What is principal axis? It is nothing but this specific line. C1, C2. Or if we talk here, C1, C2. Principal axis. C1, C2 is a line passing through optical center and perpendicular to the lens. Right? So there are two conditions for a principal axis. It should pass through optical center. It should be perpendicular to the given lens. Now, what is principal focus? We'll talk about different terminologies here. Principal focus. What is this? Right? A lens has two surfaces and hence two focal points. First focal point is an object point on the principal axis. Right? For which image is formed at infinity. That is, if we take an example of convex lens, if we take an example of concave lens, right? For convex lens, if this is f1 focus point, it will give parallel rays, right? Right. So here object point, this is object point lies on principal axis and image is formed at infinity. In the case of concave lens, exactly the same. This is object point. It will give, for the rays are coming like this, give parallel rays, right? And this virtual object here, which lies in the principal axis, f1, and the image lies in infinity. And a second focus, the second focal point is an image point. Is an image point on the principal axis for which object lies at infinity. Right? That is, the two lenses, convex and concave. Image lies at infinity. That is, rays are coming from like this, infinite range, right? And it converges on principal axis as focal point f2, giving us a image. So u is infinity. That is, object is at infinity, and image is here at finite distance. So to concave lens, again object is at infinity, and image is given at principal axis. That is focal point f2, right? Object is like this. Got it? This is concave lens. Let's focus. Okay. Now, so if we talk about focal length, what is focal length? Focal length f is defined as the distance between the optical center of a lens and the point where the parallel beam of light converges or appears to converge. Okay. Now let's talk about aperture. What is an aperture? Last definition. Definitions are very important, or the building blocks of physics. If definitions are clear, any question you will be able to solve G advanced, right? Yeah, G advanced. I'm not wrong here. In reference to a lens, aperture means the effective diameter, right? Intensity of image formed by a lens, which depends on the light passing through the lens will depend on the square of aperture. That is, intensity is proportional to aperture square, right? It's very easy to understand, right? In reference to a lens, aperture means the effective diameter, right? Intensity of image formed by a lens, which depends on the light passing through the lens, right? For example, this is my torchlight, this is the lens. The diameter of the torchlight means the aperture from which the light is coming. So the intensity is proportional to aperture square, to the definition, right? So that was it for the video, guys. Thank you so much for visiting. I hope you learned a lot from this video about lenses, right? Thank you so much.